Yellowstone National Park is one of the most beautiful places in the world. But there's something brewing under the surface that could end it all. If you think you know what it is, you're probably right. It's that supervolcano. Since its creation in 1872, Yellowstone has had its share of disasters, from wildfires to floods. It even survived an attack during World War II, when an army major planned to blow up Old Faithful and divert the park's geysers to irrigate farmland. But perhaps the biggest threat to Yellowstone is also its biggest draw, the supervolcano beneath it. Yellowstone Caldera, as it's known, is actually a series of overlapping calderas. In other words, collapsed volcanic craters. The largest of these is the one we're concerned about here, and it's so big that you can see it on Google Maps. This caldera is what makes Yellowstone a supervolcano. It's wide enough to fit 60 American football fields across it. So how big is this thing? Let's compare. Mount St. Helens, the site of the deadliest U.S. volcanic eruption in recorded history, blew its top in 1980. Its crater was less than a mile wide. The Mount St. Helens National Volcanic Monument covers an area of just over 150 square miles. Now, let's look at the Yellowstone Supervolcano. Its crater is about 43 by 28 miles. If you're anything like me, you might be wondering why we didn't notice that thing before. Well, part of the reason is that it's not actually a mountain. Volcanoes are mountains with vents or pipes that reach deep into the Earth's mantle. They come in different shapes and sizes, and they're formed when molten rock, called magma, pushes through the crust. Magma is created when rock deep in the mantle melts and recools, creating crystals and pockets of gas. These features affect how a volcano behaves. For example, the more gas present, the more explosive the eruption. Magma that doesn't solidify becomes lava, which spills out over the land. A shield volcano is made up of fluid basaltic lava that flows easily. It piles up at the vent in a broad, gently sloping mound. Cinder cone volcanoes are steep-sided and made up of fragments of lava called tephra, which includes cinders. Stratovolcanoes have steep sides like cinder cones, but they're made of alternating layers of ash and lava. Their shape is determined by the viscosity or thickness of the lava. When lava is thick, it doesn't flow far, so the volcano builds up around the vent. When it's thin, it flows farther, creating a larger base. Yellowstone doesn't look like any of those volcanoes because it's not made of lava. It's made of magma chambers. There are 3 main magma chambers beneath Yellowstone, each roughly the size of downtown Manhattan. These magma chambers are connected to a plumbing system that reaches 600 miles deep into the Earth's mantle. That's deeper than the deepest mine in the world. No one knows exactly why magma chambers exist instead of a magma chamber. Some scientists think that it has to do with plate tectonics. The North American and Pacific plates are moving away from each other, which creates space for magma to pool. Others believe that the magma chambers were created when magma pushed up through the crust and solidified, leaving behind a bunch of underground pockets. But we don't know for sure. What we do know is that these magma chambers are constantly resupplying magma to the shallow magma chambers that feed Yellowstone's geysers and hot springs. Yellowstone's geothermal features, as they're called, run on magma heat. They're powered by a constant supply of heat from the underlying magma chambers. This heat is transferred to groundwater, which turns into steam. The steam builds up pressure until it blows the water and superheated steam out of the ground. In the case of Old Faithful, this happens every 90 minutes or so. Now, you may have noticed that I keep saying magma chamber and magma chambers. We use magma chamber to describe the place where magma collects before an eruption, but magma chambers describes the multiple rooms beneath Yellowstone. So the correct term to use here is magma chambers. Anyway, because Yellowstone's geothermal features are powered by the magma chambers below, they help us monitor the volcano. As the magma chambers fill up, they push the groundwater deeper into the crust, increasing the temperature of the geothermal features and making them more active. So when we see an increase in activity, it could mean that the magma chambers are getting full. And that's something we want to watch out for, because when the magma chambers get to full, the magma could spill over the land in the form of a lava lake. Or worse, the pressure could become too great and the magma chambers could explode. That's what happened 640,000 years ago in the Huckleberry Ridge eruption. A massive amount of magma erupted and was ejected into the air. Pyroclastic flows raced down the side of the volcano at 100 miles per hour, incinerating everything in their path. Ash rained down over an area of 28,000 square miles, and a layer of ash 3 feet deep covered parts of Montana, Idaho, and Wyoming. That's the size of Connecticut, Massachusetts, and New Hampshire combined. But it was nothing compared to the eruption 2.1 million years ago at the beginning of the Pleistocene epoch. It was the largest eruption in the history of our planet. Estimates say that 2,400 cubic kilometers of material was erupted, which is enough to cover the entire United States in 1 foot of ash. Both of these eruptions were catastrophic, but luckily they happened before humans set foot in North America. The same can't be said for the Lava Creek eruption. It happened 13,000 years ago, when humans were making cave paintings on the walls of Lascaux and hunting woolly mammoths with pointy spears. The eruption threw 1,300 cubic kilometers of ash, rock and pumice into the air, covering the Great Plains in a layer of ash 6 inches deep. A pyroclastic flow swept across the Snake River Plain, destroying anything in its path. But the real damage was done by the ash. Within weeks, the ash buried most of the western half of North America under several inches of ash. Most of it fell on what is now Washington state, and it was so thick that it blocked the sun's rays, plunging the continent into darkness. This lasted for months, and when the light returned, the world looked very different. The landscape was covered in a layer of ash and soot that killed off most of the plants. The animals that couldn't migrate south died. Mammoth bones have been found with ash in their lungs. Human settlements were abandoned. All told, the Lava Creek eruption was responsible for the extinction of dozens of species and may have contributed to the extinction of the woolly mammoth. But life always finds a way. After the sun came back, plants and animals moved back into the region, and eventually, the forest came back to life. Humans returned as well, though they didn't stick around long. In the early 1900s, the US government started promoting tourism in Yellowstone, mostly to get people out of the big cities and away from the factories where they might unionize. Once they got there, they liked it so much that they never left. Today, Yellowstone is home to almost 11,000 people who live, work, or go to school there. They're not in any danger of being wiped out by a volcanic eruption, though. Scientists can tell when the magma chambers are getting full, and when the next eruption might happen. They can even tell us how powerful it will be. That's because Yellowstone's eruptions follow a pattern. They occur in 3 phases. The first phase is marked by small earthquakes that occur before magma begins to rise from deep in the mantle to the magma chambers. The second phase starts when the magma reaches the magma chambers and continues until the eruption. During this phase, the earthquakes get bigger. The third phase is when the eruption occurs and ends with the collapse of the volcano. Each phase can last anywhere from a few months to a few years. And although scientists can tell us when the next eruption will take place, they can't tell us when each phase will start or how powerful the eruption will be. So while no one would notice a small earthquake in such a remote location, it would still be recorded by the local seismographs. If that happened, it might be time to pay attention. But the Yellowstone Supervolcano isn't our biggest concern. The real problem is climate change. The warming climate is causing the snow and ice in the Arctic to melt, which raises sea levels and threatens coastal communities. Not only that, but it's also leading to more extreme weather events like hurricanes, floods, and droughts. To learn what you can do about it, visit the website below.